Hello friends, so today in this short video tutorial we are going to explore how to improve write performance while working with lakehouse file formats. For example, it can be Apache Hudi, Iceberg or Delta table. So for almost all of these file formats, there are two patterns to write the data. One is called cow, another one is MOR. Cow stands for copy on write and MOR stands for merge on read. So suppose here we are having a delta table that can be created in AWS Glue data catalog, or that can be in Databricks platform in Unity catalog, and that delta table data actually stored in some cloud storage, for example AWS S3 or Azure Blob Storage. Currently it is having 3 Parquet file, a.parquet having 10 rows, b.parquet having 5 rows and c.parquet having 20 rows. Okay, and apart from the actual Parquet data, it is having transactional logs also stored in S3 location. Now suppose you have applied a delete command on top of this delta table, and as a result 5 rows are deleted, and let's consider all 5 rows are available in c.parquet file in the cloud storage location. So after the delete operation, how the file structure will be in our cloud storage? So that time a.parquet and b.parquet will not at all be touched, so it is having same state data, but because the 5 rows which are impacted due to delete command, if they are available in c.parquet, so what will happen that this parquet file will be deleted and there will be an update in transactional log that c.parquet is removed. That's why it is highlighted with the red color, and out of 20 rows, apart from those 5 impacted rows, whatever 15 rows are remaining which are not at all impacted in c.parquet, those will be written as a new file, for example d.parquet, where those 15 unimpacted rows from c.parquet file will be there. Right? So this is the general flow while applying any transaction on top of our DeltaLake. Now try to understand the problem associated with this approach, and that is here unnecessarily we need to write 15 unchanged rows in a new Parquet file. That is basically increasing the time taken to write the data in a way. Or if you consider another situation, that delete command is impacting only 2 rows, one from a.parquet and one from c.parquet. So that time the rest 9 rows from a.parquet need to be copied or rewritten to another new Parquet file, and same goes for c.parquet file, that rest unimpacted rows need to be written in another Parquet file. Right? So obviously I hope you are getting this, that lot of unnecessary data copy is happening in this write process. That is number one. And if the impacted rows in delete command or update command is distributed across multiple files, that time lot of new files will be created. And another important point is these removed files, for example c.parquet, will be still remaining in your S3 location until and unless next vacuum command is getting executed. Right? So as a result, it will be increasing the storage cost also. So I hope you are getting that in this process, storage cost is increasing, write operation is becoming very heavy due to this unnecessary data copy. Rather than that, can we follow some optimized approach using which we can avoid this unnecessary unimpacted data copy operation in some new Parquet file? That is the question. And that's where comes merge on read operation, using which you can improve the write performance. That is, time taken to write the data will be improved if you follow MOR pattern or merge on read. So what it does, suppose here we are having a delta table and we are executing some update command, and due to which 2 rows are impacted, for example second row and 4th row. So in merge on read process, instead of writing the backend Parquet files in new Parquet file, what it does, it tracks the impacted data in another data structure like this. Here you can consider another data structure is available along with our actual table, where basically it is having an indication that this row is no longer useful. This row is impacted rows. That's why its state is 1. Right? For each row ID in our table, there it basically tracks whether it is 0 or 1. 0 means this particular row is valid, it can be used. 1 means this row is no longer valid, either it can be deleted or it is having some new version or update which is available in some other row, like that way. And this particular data structure is called as deletion vector, because this data structure is storing the information that whether the row is deleted or not. That's why such name is there. So in merge on read process, what we do, that track rows that are changed in a separate data structure like this way. That way what will happen, for example, in c.parquet 20 rows are there and we executed a delete command where 2 rows got impacted and both of the rows are from c.parquet. That time rest 18 rows we no need to rewrite in d.parquet. Rather what we'll do in this vector, we'll be updating that these 2 row IDs are deleted in deletion vector. So track the rows that are changed in a separate data structure, and in delete case there will be no new file will be written because rest 18 rows are available in c.parquet only. But if it is update command, then the new rows will be written in a separate parquet file alone. So that way from that earlier parquet file, for unimpacted rows, unnecessary data copy is not happening in this process. So for deletion, we are maintaining a separate data structure, and if it is update command, that time if some rows are deleted, for those rows we will be having new state. That new state data we can store in a separate parquet file, right? So we'll be having 2 information. One is deletion vector, one is new parquet file. And when we will try to read the data from this delta table, it will be the responsibility of our delta table and the client to do the computation. Based on deletion vector, it will be having a lookup that whether the row is valid or not, and if the row is valid, that alone it will be taking. And for deletion vector with state 1, it will be ignoring those rows, and new rows it will be taking from the separate parquet file where those new rows alone are available. So this way in merge on read process, the write operation will be optimized because that many unnecessary data copy will not happen. But obviously I hope you are getting this, that read time for your query will be little higher because it need to compute the current state of data based on deletion vector. So during read operation, that computation is happening. As a result, merge on read process, although optimize write performance, but if your table is read heavy operation, then better to stick to copy on write. Because in copy and write, directly you read the data. For read operation, no computation we have to do. So this is the 2 ways, copy on write and merge on read, which are very popular pattern for write operation in our Lakehouse platform. This is all for this video. Stay tuned for more such interesting concepts.